All right, so one thing that I noticed a lot of people do, and students, including tutors, is that when they talk about or when they write out proportionalities or relationships, they use arrows. So let's say we had a passage that told us that ATP is is proportional to let's say like GTP. So a lot of times people would do something like this. They'd say, okay, if ATP goes up, GTP goes up. And then let's say if ATP goes up, ADP goes down. What they write is, ATP goes up, ADP goes down. Now, that seems fine and all, but I'll show you why this can be very, very misleading. In actuality, mathematically speaking, that is, you would establish a proportionality using the proportionality symbol like this. And if it's a direct proportion, like it would be like for ATP and GTP here, it would be ATP proportional to GTP. Okay. Now, if we were to graph this out with this linear proportionality, right? With, let's say ATP here, GTP here, it should just be a linear line that increases like that, right? Now, okay, now let's think about this ATP ADP proportionality. So if ATP goes up, ADP goes down. So what the proper way to write this would be proportional to 1 over ADP. And let's think about what that looks like. Now, most people would think, okay, if the direct proportion is this straight line going up like that, it should just go down like this. But no, that is not what happens. And you can actually figure this, you can actually test this out yourself. What if we included, why don't we put in some numbers here? So let's say, I'll just call it A for ATP. And then for the ADP, I'm just going to say 1 over B. So when A is 1, 1 over B is 1. When A is 2, 1 over B is 1/2. When A is 3, 1 over B is 1/3. Let's go a little higher. Let's do 500. When A is 500, 1 over B is 1 over 500. If I were to plot this, 1, 2, 3, it would be like, well, it would be like, let's see, I'm just going to put a 1 over here. So, and then 1/2, 1/3, etc. So here, 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 it would look like it would curve like that. And if you ask yourself, what number can this be not be? The number in the denominator. Well, it can't be 0 because 1 over 0 is undefined. What this also means is that the axes here and here are asymptotes, which means that the curve or the line will infinitely approach the axes, but never touch the axes. It's like the paradox, I think it's Zeno's paradox, where let's say you're walking towards your door and each step you take is 1/2 of the previous step. Will you ever reach the door? Well, the answer would be no. So this is why this type of way of writing proportionalities is the correct way, because you can answer questions like this. This question's asking what's the shape of V naught versus substrate concentration. So the linear would just look like that. Sigmoidal, which is S-shaped, would look like that. Parabolic would look like that, which is exponential. Something like A is proportional to B squared. But the hyperbolic, that's when you'll get either this, or in the case of Michaelis-Menten here, something like this, because Michaelis-Menten also has an asymptote at Vmax. Anyway, I hope that was helpful. Please like and subscribe. And you know, you can leave stuff in the messages if you want to request any question for me to go over.